All right, welcome to day 3 of our chain rule lesson. So now we're going to use the chain rule in some different contexts. We're going to see some AP style questions with the chain rule as well. All right, so we have f of x equals sine of 3x. We see our composite function there. We have the 3x inside the sine x function. So that's a signifier that the chain rule is going to get used. All right, so this one asks us to find the second derivative, f double prime of x, and then we're going to evaluate it at this point over here. All right, so we'll start with the first derivative, which is going to be derivative of sine is cosine. Keep the inside part the same, 3x, and then you want to multiply by the derivative of the inside, which is 3. I'm going to put the 3 in front, and it's not sine, it's cosine. 3 cosine of 3x. All right, so now we're going to find the second derivative, f double prime of x. We have our 3 in front. The derivative of cosine is negative sine. Keep the inside part the same, 3x, and then we're going to multiply by 3, which is the derivative of the inside. All right, so I'm going to multiply that 3 times the negative 1 times the 3, and I'm going to get negative 9 sine of 3x. So there's my second derivative. Plug in your x value from your point, because we just have an x as an input over here, f double prime of pi over 18. Seems like a weird value to be plugging in, but it makes sense when we have the 3 inside. Negative 9 sine of 3 times pi over 18. 3 over 18 reduces to pi over 6. And sine of pi over 6 is equal to 1/2. So multiply those together and you get your answer of negative 9 over 2. All right, next couple problems. We're just finding g prime, and we're given this function g that's written in function notation. So we are just going to have a g prime that's in terms of f. All right, so we take the derivative of the left side of the equation, and we get g prime of x, which is exactly what we want. On the right side, we're going to use the chain rule. We have a function 5x inside our function f. So derivative of the outside function first, f prime. Keep the inside part the same. Multiply by the derivative of the inside. Rewrite it with the 5 in front if you like. And that's all you can do. All right, part B. Give it a try on your own. Unpause the video, come back, see how you did. Okay, so we get g prime of x is equal to f prime of x cubed multiplied by 3x squared. 3x squared times f prime of x cubed. Again, the rewriting is not required. I just think it looks better in that order. Okay, displacement of an object in harmonic motion is on the end of a spring is given by this equation, where y is measured in feet and t is measured in seconds. All right, we're going to answer a few questions about this. So it's kind of like a particle motion type question that we will look at more in depth in a later lesson as well. So first thing I want to do is kind of describe what's happening here. So displacement is the same thing as position. So we will often refer to the position function. So sometimes problems call it the displacement function. Same thing. Those are synonyms for each other. All right, harmonic motion. This is something that you'll talk about a lot in your physics class. Just a brief explanation of what that is harmonic means you're going back and forth. Okay, so if you think about this problem, we're hanging something on an object on the end of a spring. So if you put an object on the end of a spring and you drop it, that spring's going to go down, and then the spring's eventually going to pull that object back up, and it's going to bounce up and down, up and down, up and down. All right, and so this function should make a lot of sense with that scenario, because that's what sine and cosine do. They go up and down, up and down, up and down forever. All right, so that's how all this is kind of coming together. All right, so problem A, it says determine the position. Remember, position and displacement are the same thing of the object when t is equal to pi over 6. So this is a simple plug and chug. We're plugging pi over 6 into the function given to us, because that is the position function. All right, and then we'll work it out. So this is 1/2 cosine of 2 pi over 3 minus 1/2 sine of 2 pi over 3. So we get 1/2 times cosine of 2 pi over 3 is negative 1/2 minus 1/2 times, and sine of 2 pi over 3 is square root of 3 over 2. So we get negative 1/4 minus square root of 3 over 4. Combine those together if you like into a single fraction because they have a common denominator. And let's put units on this. Y is measured in feet. So this is in feet. All right, so what this answer is telling us is that since it's a negative number, is that the object is that many feet in the negative direction of where it started from. All right, so you can have a negative answer for position because your position answer is based on where you started from. So like if you're going on a horizontal line, if you go to the left on your horizontal line, you're going to get a positive value. Sorry, if you go left on a horizontal line, it's going to be negative position. And if you go right on a horizontal line, it'll be a positive position. All right, next one, find the velocity of an object at any time t. So velocity is the derivative of position. Same thing, derivative of displacement. So v of t is equal to y prime of t, because y is our position / displacement. So we're going to take the derivative. We have our 1/2. Derivative of cosine is negative sine. Keep the inside the same, 4t, and then multiply by 4 for the chain rule. Second term, minus 1/2. Derivative of sine is cosine of 4t, and then multiply by 4, which is the derivative of the inside. Okay, let's simplify. 4 times negative 1 times 1/2 is negative 2 sine of 4t. And then 4 times negative 1/2 is negative 2 cosine of 4t. All right, so that is it. That's our velocity function, which is what they wanted us to find here. And then part C is going to ask us to plug a number into the velocity. So this is asking us to do v of pi over 6. All right, so that's going to be negative 2 sine of 2 pi over 3. We already saw when we plug in pi over 6, we get 2 pi over 3 on the inside, minus 2 cosine of 2 pi over 3. And that's going to be negative 2 times the square root of 3 over 2, minus 2 times negative 1/2. So this ends up being the negative square root of 3, and this ends up being positive 1. And looks a little better if you write the 1 first. 1 minus the square root of 3. All right, velocity is a rate of change. When you took the derivative, you created a rate of change that's in feet on top per second. So this is the same thing. Y prime, remember, is dy over dt. So dy is in feet, dt is in seconds. So your answer here is in feet per second. All right, on the back, we have a graph. If you've been following along with my videos, you've seen this graph before. We did it in our product and quotient rule lesson. And in fact, parts A and B are in the product and quotient rule notes. So I'm going to flip back to that real quick just so you can see them. All right, so this is our product and quotient rule day 2 lesson. And here are those 2 problems right here. So go watch that video again if you need some help on those. So I am going to focus on the chain rule versions of these. All right, so I'm just going to make a note right here on product quotient day 2. All right, so we're going to focus on the chain rule questions here. Okay, so we are given a function called p of x, which is f of g of x. We have our composite function, which means we're going to have to use the chain rule, and then we're going to be plugging in 6. So let's take the derivative, p prime of 6. I'm going to go ahead and plug in 6 right now, just so I don't have to write it twice. Start with the outside function, f prime. Keep the inside the same, g of, and then 6 instead of x. And then make sure you multiply by g prime of 6. All right, so now we're going to use our graph to find these values. So we're going to have f prime of g of 6. So let me go up here. G is my bold function, and then 1, 2, 3, 4, 5, 6 is right here. and that is this point. So that point is positive 2. So now I have f prime of 2 multiplied by g prime of 6. So g prime is the slope of this line. So that's negative 2 is the slope of that line. So negative 2. All right, so now I need to find f prime of 2. And so now I look at my f graph, which is the less bold graph, and 2 is right here. And all right, I get this point. So we run into a problem here. This is a sharp turn. Okay, if you look at the slope on the left side, you get a slope of positive 2. If you look at the slope on the right side, you get a slope of 0. Those slopes do not match. So the derivative of f at x equals 2 does not exist. Okay, which means that we cannot do this problem. Our answer is does not exist. Does not exist because f has a sharp turn at x equals 2. All right, which means that f is not differentiable at x equals 2. So you could also say that instead because f is not differentiable. I'll put an or here. I like to say sharp turn because I want to give a reason why it's not differentiable rather than just stating a fact. But I've seen on answer keys of problems like this on the AP exam that they just say f is not differentiable at x equals 2, and that's usually acceptable. All right, let's take a look at this last one. We have t of x now, another composition, g of f of x, and then we want to find t prime of 7. So I have t prime of 7 on the left side is g prime of f of 7 multiplied by f prime of 7. All right, so let's go to our graph and find f of 7. So 7 is right here, and f is the less bold graph, so f of 7. All right, so I'm kind of right there in the middle, and I don't want to make any assumptions that it's exactly in the middle. It might be, but I want to kind of verify this. So this point right here, this is 1, 2, 3, that's 4, and this point right here is 3. Okay, and then the slope of this line, I know the slope is negative 2 over 4. So the slope of this line is negative 1/2. So I know that if I start at this point, I can go down 1/2 and over 1. Or if I start at this point, I can go up 1/2 and left 1. Okay, so this is in fact right in the middle. It is at 1/2. This is at 3 1/2, which would be 7 over 2. I'm write it over here, 7 over 2. All right, so that is our f of 7. So g prime of 7 over 2 multiplied by f prime of 7. So that's the slope of that line we were just looking at, which we already identified was negative 1/2. All right, so now I'm going to find g prime of 7 over 2. So 7 over 2 is 3 1/2. So 2, 3 1/2 right here, 7 over 2. That would correspond to this point on the g graph. G is the bold one, but I don't want the actual point. I want the slope. What is the slope of that line? G prime up to right 3. So g prime of 7 over 2 is 2/3. F prime of 7 was negative 1/2. You can cancel the 2's out, and you're left with negative 1/3. All right, hopefully you enjoyed that video, and I will see you on the next lesson.